Alright, for this activity you're going to need to get two things out of your bag. First is going to be this sheet right here. This is going to be the one that we're going to turn in, and we're going to draw free body diagrams, vector addition diagrams, and motion maps onto. So these are where you're going to draw things. And then you need your bag of cards. Okay? And they're marked with the FBD. So I'm going to take the cards out first. Now what you'll want to do is, again, this is another one of those sorting activities. So really we want to put them into various piles to pull from. Now you're going to see ones that look like this. This is a vector addition diagram. So I'm going to put those in one pile. This, okay, is a free body diagram. And the difference between them is, again, free body diagrams always start with the object's center of mass right there. And then it has the arrows going off of it. Where the vector addition diagrams actually go from the arrow's tip to the tail, and they always try to connect them. We'll talk more about those. But that's going to be the first thing, is to separate them. And the easy way to tell, again, is that there's letters on the free body diagrams, but not on the vector addition diagrams. Now these are the situation cards, and those are the situations that will match everything that's on the sheet. So we're just going to make sure we get all of the situation cards there. So vector, there's free body diagram. So we're just going to go through and sort. Alright. Yeah. Now these are motion maps, okay, and you're going to see a motion map. They're actually marked, and those go into a separate pile. And so we've got a number of different motion maps. Alright, so you should have piles of the free situations, the free body diagrams, the vector additions, and then the motion maps. Okay, so here's how we're going to kind of go through and do this. So we're going to try to pick out a situation. Okay, now it doesn't matter which one you start with, and so that's why once we find one, we're going to match them and we're going to get them cleared out. But like, I'm going to take this situation because it's on the top. Okay. Now I'm going to go ahead and I'm going to find that situation on my sheet, and I can see it's right here. So I'm going to go ahead and do this. That's the situation that we're going to work with. We want to think in terms of what would the free body diagram look like. Now at this point you guys are pretty good with free body diagrams, so you may want to try to draw it first. So like, if I look at this, I know that that block, that's the center of mass for that block, and I know that there's going to be a force of gravity pulling down. So this is going to be a force of gravity pulling down. Now, when you draw them, you do need to put labels on them. So I'm going to label this with force, gravity, okay, going down. Now the next thing I'm looking at, I see that there is a cord pulling this way and a cord pulling this way. So these are actually tension forces. So I've got a tension force that wants to pull this way and a tension force that wants to pull this way. So I'm going to go ahead and I'm going to go tension force this way and a tension force this way. Now that's really the forces that I should be looking for. So let's see if I can find that free body diagram out of the pile. So these are my choices. Now I'm going to go through kind of what I see here. So always keep the letter up in the corner. This way you've got it oriented the correct way. So they're all going to have an arrow down, so that's going to be a force of gravity. there's a force going this way. That matches so far, but this arrow doesn't match, so that's not what I'm looking for. This one is just an arrow pointed down, so that doesn't work. This one right here is got 4 different forces, and I only think I have 3. Oh, there we go. So there's a force pulling down and a force pulling across and a force pulling this way. So that one looks like it matches, so I'm going to set that one out. So that's going to be my 1. And you can just kind of go through, double check, but you're going to notice that they all have a force of gravity, and then they have forces going in various directions. And again, you're going to have to label the forces when you go through and draw them on your paper. So make sure that you're labeling your forces. Alright, so I think I'm through those. So now it gets into the vector addition diagram. Now this means that I'm looking for one that's going to have 3 arrows, and I'm going to take the arrows and go like tail. Okay, the tail is the back side of the arrow and the tip is the front side of the arrow. So in other words, that arrow points this way. I should have like an arrow that's going to point this way, and then I'll have an arrow that's going to point this way. So this one should almost go in a triangle. Now one of the things that I notice about this is that this block is motionless. So when it's a motionless block, that means that all of the arrows in the vector addition should end up touching, and that's going to show that it's balanced. So I'm looking for a balanced vector diagram with no gaps. Now this one's only got 1 arrow in it. Okay, this one's got a gap in it, and so that one shows acceleration. So that means that there's going to be a net force acting on that one. This one has 4 arrows, but it is balanced. So in other words, that one balances out. Here we go. I've got one that's got 3 arrows. Let's double check. So if I turn it this way, okay, I'm going to have an arrow that's pulling this way, arrow pulling this way, arrow pulling this way. That should match. So I got arrow, arrow, arrow. So there's my vector addition. So what I'm going to do now is I'm going to draw that in to my situation. Okay, so I'm going to take my pencil here. I'm going to draw the arrow that goes this way. I'm going to draw an arrow that goes this way. And then I'm going to draw an arrow that goes this way. So there's my vector addition, and it shows that this is going to be balanced. So all the forces here are balanced. No net force. Okay, so now I need a motion map that shows no motion. Okay, so I'm looking now at the motion maps, and I'm going to try to find one that has 0 motion going on. Now this one has arrows on it, so I know that one's going to be moving. Oh, here's one. So this one just has dots with no arrows. So when you see one that has dots with no arrows, that means that we are not moving. So that motion map is going to match. Okay, so I'm going to go ahead and draw my motion map in here, and it's just dots, and I'm going to show not moving. Okay, and then once I've got all of those cards together, I can go ahead and set those aside so I don't use those anymore. And now you can go back to working through. So you want to do this with each of our situations. Okay, pick out your situation, pick out the free body diagram, remember to label it, draw in the vector addition diagram, and then the motion map. So you're going to fill each of these out. Now you're going to have 2 extra free body diagrams, okay, and motion maps. And so you'll need to make sure you match those first, and then you're going to have to, two free body diagrams and 2 vector addition diagrams. You're going to draw those in here, and you're going to figure out what the motion would be for them. So figure out your motion map, and then you're going to draw a situation. So you're going to complete this with drawing in 2 situations and 2 motion maps for the extras that are left over. When you are done with this, you're just going to post this, take a picture, post it to the assignment. Okay, if you have questions, just ask, and we can get those questions answered.